Hello and welcome back to SN Tutors. Topic of today, resonance. Now the first thing you should know about resonance is that when you're drawing resonance structures, it is the same molecule. You're not changing the connectivity at all. You're not changing anything about it, just the distribution of electrons, but only the delocalized electrons. Some electrons are localized and cannot be moved, such as bonding electrons and localized lone pairs. So let's go through an example. We'll start off simple. Here's a benzene ring, and let's just go through and draw a resonance structure of this. Right? So what's the first thing you do? If you see electrons that you can move somewhere and then a pi bond right after that, then you're going to have resonance. And trust me, once you do enough practice of this, it's going to be second nature to you. So this is the most classic example in all of Orgo. That's how you draw the arrows. It starts at the source of the electrons and you show where it's going, where it's going to end up. So take a minute and pause the video and try and draw the resonance structure yourself before doing this. Okay, so you pause the video. Now you're back. And so let's see what it'll look like. Fairly simple, just this, boom, done. There's your resonance. So now let's look at some other examples. We'll look here. So this is a really important resonance structure or type of resonance because this is important in amino acid chemistry, right? Although usually this isn't an H, you have another group attached and another amino acid and it keeps going. But let's draw on these lone pairs and see what kind of resonance we can draw. So here, can we move these lone pairs? Are they localized or delocalized? Right. They are localized, so we cannot move them. Because if we move them here, there's nothing to move down here that this will take the place of, right? Because if I move this down, then carbon's going to have 1, 2, 3, 4, 5 bonds. But carbon is tetravalent. So if it has 5 bonds, it's going to be exceeding its octet, and it can't do that because it doesn't have access to the d orbital. But enough of that. Let's look over here. This is delocalized because when we move it here, sure, you're forming another bond with this carbon, but you are going to be able to move this up here so that you keep those 4 bonds to the carbon. So then your resonance looks like this. Oh, and by the way, these resonance arrows are very specifically linked to resonance. So when you see a double arrowed line, that's resonance. This means equilibrium when you have like 2 arrows, right? Just get rid of that real quick. So let's draw this resonance structure. So take a minute, try it yourself. And resonance is probably the most fundamental part of organic chemistry because it essentially tells you a lot about reactivity of certain electrophiles and a lot of other things. It could like electron withdrawing groups, electron donating groups. So yeah, make sure you know your resonance. So you got to keep an eye out for formal charges, right? Because now this has 3 lone pairs. 2 of them are localized, 1 of them is delocalized. That's the one that we moved up there, right? But now this lone pair is now in the pi bond. So how many things do you have attached? 1, 2, 3, 4. Nitrogen makes 5 bonds. So it's a plus formal charge. So there's your resonance. Okay, so yeah, make sure you guys review resonance. It's extremely important. Thank you for watching the video. I hope you found it helpful. And if you have any questions, please leave it in the comments and subscribe to the channel. Thanks. See you next time.